For this week's concept map, I did my research on decision trees. A decision tree is basically a decision support tool that uses a tree-like model of decisions and their possible consequences to display an algorithm that only contains conditional control statements. Basically, decision trees ask a series of true-false questions to narrow down what class a specific sample population belongs to. So on the screen, we have a sample decision tree where you can see that there are a bunch of true-false statements that lead to other true-false statements, which eventually lead to a decision or consequence. To simplify decision trees, I have made a real world decision tree on whether to bring a coat, an umbrella, or a raincoat. So basically, the first question is whether it's raining or not. And if it is, then you go down the if it is, you go down one path, and if it's not, then you go down the other path. Now there are two typos I made on this chart. One is the first question should be in square instead of circle, and the second one is I forgot to write the yes on one of the branches, but let's just pretend it's there. So basically, it asks you a series of questions that eventually lead to other questions and eventually lead to a decision of whether you should bring a raincoat, an umbrella, or a normal coat. So the advantage of a decision tree is that they're visual and simple while still providing effective results, such as validating models using statistics. The disadvantage, however, is that sometimes trees can be overcomplicated while not generalizing data very well, which is called overfitting. Decision trees are useful in real world decision making, predicting possible outcomes, and visually and explicitly representing decisions in machine learning. They are useful in decision making in machine learning and real world application because it provides a clear visual representation of specific path to a result. It has the potential to simplify complex situations by providing a representation of the situation. So in making a decision tree basically have three main parts: the root node, the branches, and the leaf nodes. So despite the name, a root node is actually at the very top node and is the first decision you're trying to make. The branches represent different options or courses of actions that will lead to the result. Leaf nodes are the possible outcomes for each decision. The two kinds of leaf nodes are square leaf nodes and circle leaf nodes. So square leaf nodes are leaf nodes that indicate that there are going to be more decisions to be made after, while circle leaf nodes indicate an unknown outcome or consequence. As we can see on the screen, we have the basic structure of a decision tree. Of course, in complicated machine learning, decision trees become much more complex and contains many nodes and branches. This is just a very simple basic structure outline, and in real world machine learning, things can become much more complex. So to put it into perspective, given the example that was shown previously, we can see that the root node is the very top one, which asks if it's raining. The branches are the arrows that say yes and no, and while the leaf nodes and the leaf nodes are the ones that are after the branches and after the root node. So for a comparison model, a decision tree can be thought of as a flowchart like the one shown on the screen, a flowchart that eventually lead to get an answer basically. Generally, flowcharts guide you along certain paths that lead to more charts/questions. Likewise, a decision tree leads to certain questions that eventually get a result. Just like decision trees, flowcharts can get extremely complicated if not organized very well, which is one of the disadvantages of a decision tree, as mentioned earlier about overfitting. Now, on the other hand, flowcharts can provide very good visual representations of specific paths that lead to a result. So it can provide a simple visual representation that would eventually lead to a result or consequence. So overall, this was my presentation on decision trees. Thank you.